Hello, everybody. My name's Dave Ward. I'm the Managing Director of Time. Welcome to this very, very special session. And this is the third of our autumn series of webinars. And I'm going to introduce you to Tom Garner from the University of Portsmouth, the School of Creative Technologies. A very, very special place. This school is one of our James Integrated Learning Centres. James, our sister company, gives industry accreditation to music courses and courses related to music technology and the arts. I had the privilege of visiting them earlier in this year, and the facilities down there absolutely blew my mind, and which is not unusual in itself. And so we'll be hoping to look at doing some much more work with the University of Portsmouth later in the year. But right now, please give a big welcome to Tom Garner. I'm really looking forward to this, demystifying VR and AR. Tom, over to you.
Thanks very much, David. Thank you, everybody, for joining me. It's wonderful to get an opportunity to talk about this. My background is very much in music performance, and then later a master's in music composition. That was kind of my forte. It was really where I kind of started in my academic career. And in the last few years, it's been kind of a bit of a fight to be able to keep that music and sound kind of alive. This sort of technology, as you can imagine, the graphics come first. What you see tends to come first. You know, the eye takes precedent over the ear. And you kind of need to put up a little bit of a fight to argue for sound and music's corner sometimes in this particular technology. So any opportunities like this to really kind of, start, get into this kind of side of the development space is always something I'm really happy about. So I will start with something horrible. If you bear with me, I will just move on to the next slide. Turn this up to make sure you can hear it. Hopefully you can. Right, I'll stop there and leave you alone. I hope you could hear that. So kind of partially hope you couldn't hear it, but this was just something I wanted to kind of start with in terms of how is sound kind of relevant to virtual reality in particular. And this was a very rough proof of concept which we put together just to kind of show how one very key mechanical affordance of virtual reality technology, specifically head tracking and hand tracking, could be connected to sound to experience sound in a virtual environment in an interesting way. So in the simplest form, all we really have is you have a virtual object which you can pick up, in this case the dentist drill. When I pull the trigger on that controller, it will start that spinning of the drill, and then as long as I'm holding that button down and the drill is making that sound, if I then move that virtual object through my hand physically to my mouth, as long as it's close enough, it then starts making that grinding sound on the teeth that fades in over the top. And yeah, drilling your own teeth, it's a very surreal experience, but it was a nice way of being able to illustrate the sorts of new affordances that you could do with this particular type of VR technology. So the biggest problem I had in kind of preparing for this was thinking, like, what can I not talk about? Because within a limited amount of time, to go over an awful lot of the fundamentals of just virtual reality, is a multiple part, could potentially be a multiple part series in itself. So I'm going to try my very best to keep it to the most essential aspects, and then if there are kind of any further questions kind of later, it'd be great to follow up on them. But I tend to start when I'm explaining kind of the fundamentally, whether it's to a client or to a student, about, you know, well, what even is extended reality? I've heard this as a newfangled term. I think I maybe know what VR is, but what on earth is extended reality, and how is any of this technology remotely relevant to me? How might I use it for my product and service, for my business, or what have you? And this continuum by Milgram and Kishino is what I would most prominently use to differentiate the core kind of areas within extended reality. And we start over the right-hand side with what we're all kind of ideally most familiar with, reality. And in the most fundamental sense, we're talking about everything in that experience, what we perceive, everything which we receive in terms of sensory input is all generated from, it's all from the real world. It's physical, it's reality based. And then you have augmented reality, where again, at the most basic level, we're talking about feeling like you are fundamentally present in that physical world still. You're still in the real world. You feel like you're interacting in the real world. You feel like you're present in the real world, but that experience is being augmented through some form of virtual overlay. So that could be some floating text, floating graphics. So, you know, you'll probably see a lot of the promotional videos for things like the Microsoft HoloLens, or people playing Pokemon Go, and there's virtual graphics overlaying a real world content, either through the camera or literally just us seeing it in the world, and then the virtual content being projected onto the inside of the lens. And then when we move a little bit further towards the left of the spectrum, we end up with probably the section of extended reality that people are least familiar with, but at the same time is, I would argue, one of the most exciting, and simultaneously totally what I'm going to be talking about for the rest of the session. It really fits into this third category, and this is this idea of augmented virtuality. In order to explain that, I'll leap over it and just go to virtual reality, which is that sense of, unlike AR and reality, you feel very much as if you're experiencing, you're present in the virtual world. There's a sense of a full immersive environment in which you're situated, and that environment is not technically real, or it's not physically based. It's not the real physical world. It's a virtual construct that you feel present in. Augmented virtuality, you still feel like virtual reality, that you are present in that virtual world, that virtual space, but that virtual space is not entirely virtual. It's being influenced by lots of real world content. So very much kind of like the flip of augmented reality, taking different forms of data from the real world and injecting them into the virtual world. And we feel like we're present in the virtual world, but it's a far more exciting and interesting virtual world because there's this wonderful overlap and interplay between real world content, real world data, physical content, environmental data, all these kind of things, which we'll talk about in a moment, that are all coming together within a singular experience, but one that you feel completely immersed in, unlike augmented reality, where it very much feels like an overlay of otherwise the real world. And this, I can never resist showing this when I do similar talks, because I like to illustrate the point of just how interconnected so many different elements are, in terms of academic disciplines, in terms of technology, and in terms of us as humans. There's so much that comes together to create this web of what is ultimately sound within virtual reality and sound in augmented and extended reality. So the nature of changing hardware over time, the nature of us as humans, our physical form, so our physiology, the nature of the sensory modality with which we're experiencing this kind of content, the nature of how we interact with it, how those interactions are designed, the interfaces, the nature of kind of existing technology, or kind of like complementary side type technology like the smartphone, for example, or like a console for typical PC gaming, that sort of thing. There are so many different things that can affect particularly what VR sound is and XR sound is, but what it should be, or what good VR sound is, you know, how to make an experience which is a good experience as opposed to just one that is superficially using the technology and the audience are being drawn to the fact, oh, well, this is fancy, it's using this technology, I've never seen it done before, it's novel. Obviously, this sort of tech can't be novel forever. And ideally, it doesn't want to be novel forever. It wants to become ubiquitous. It wants to see consistent uptake. It wants to see growth. It wants to see people seeing how it could be used in a more everyday context rather than just in these one-shot special events that are all very novel and interesting, but never really take off. You know, a lot of this technology and the design around it wants to move into a more permanent home. It doesn't want to be nomadic, or people who work in that area, these areas, myself included, don't want it to be nomadic. And the next slide here covers what I would say is the theoretical underpinning of a lot of my own work that feeds into sound design, music composition as it relates to virtual and augmented reality. And this idea that, again, going back to one of the earlier slide that just showed so many things being deeply interconnected, this idea that you always have a listener. There is always a human. The old adage of, you know, if a tree falls in the wood, does it make a sound? No, would be my philosophical answer to that. It makes something. There's a waveform, a sound wave maybe. Feel free to debate me on this one. But there's a sound wave, but there's not a sound. A sound needs to be experienced, and there needs to be a listener. And it's the interplay, it's the relationship between the listener, their form, the environment in which they're present, and the other aspects in that environment that are coming together to create that singular experience of sound. And if we want to be able to manipulate that sound, whether it be like a sound effect or a vocalization or something musical, we are best placed if we fully understand all of this context. You know, we don't look at single elements in isolation. We think about the relationships and how these things all kind of come together to create a singular emergent experience of what sound is. And the more we understand those elements that form that emergence, the better, hypothetically at least, we can manipulate it and craft it in a way which means we can have a stronger sense of what the effect it's going to have on the listener. Is it going to be good? Is it going to be bad? What does good and bad even mean? Does it have the cognitive impact we want it to have? Does it have the emotional impact we want it to have? The more we understand elements like these perceptual components of memory, which can feed into the user's expectation, what they've experienced before, will influence how they experience something now, to aspects of their physiology, and this could be something as fundamental as their height and their weight, their body proportions. It could be their health status. There's so many different things which could potentially impact the nature of a sonic experience, of how it makes them think, how it makes them feel, what sort of state, trait, effect it can have on them. And this just is a big one, lots and lots of stuff here. Obviously, if there are any particular terms, oh, what on earth does that mean? Feel free to just make a note of it and go, Tom, what on earth was that one? That looked like an interesting word. I've never seen that. Is that even a real word? Are you making all these up? But the idea here was really to start applying that model of emergent perception as a way of kind of moving from the extreme left and right, which in this instance is on the left, the technology, what it fundamentally is, the hardware, the actual physical nature of what the hardware and the technology is, with either virtual reality or augmented reality or whatever the technology is, but it's the nature of what that technology is at a fundamental technical level. And then on the other side, you've got the user, and understanding them in almost exactly the same way, what they fundamentally are, their brain state, body state, what's the environment in which they're situated, and then these other perceptual and then wider influential factors. If we understand those two things, it's then possible to then move one kind of step further inwards and kind of infer things. So we can observe the user, we can observe the XR system, but then we need to kind of contemplate what that means. And so in terms of use of sound, based on our understanding of the user, we can start understanding or inferring what their experiential quality of certain sounds is likely to be. We can think about how they might be listening to a particular sound, or how they might be engaging with a particular song, a piece of composition, a piece of music. Are they listening in a way which is much more reflexive? They just kind of, there's no thought, it's just they want to have an immediate knee-jerk experience. Or is it something where they're right at the other end of the spectrum, is they're primed to be very critical? I can imagine at least a few of you will have experience of this, of doing a gig in front of what I would argue is by far the worst possible audience, which is a bunch of music students or music academics, or basically your peers. You know, so there's no one in the audience who is there just to consume your music and enjoy your music performance. They all sit there around the tables and they don't move apart from the occasional kind of, they're doing this. They're pulling apart everything you're doing. You're trying to express and create some sort of dialogue between yourself and the audience, and you're getting no feedback apart from, interesting, yes. It's quite devastating. But depending on who your user is, who your audience is, you can potentially make some inferences as to how they're going to engage with that sound content. And then on the other side, from the better you understand the XR system, you can better understand what you can do with that system in terms of its technological affordances to shape the sound. And then when you know what you can do with the tech to shape the sound or the music, you know what the user is, how the user is likely to engage with the sound through the user analysis. You then move to the center and have a number of different things that you can infer, an inference of an inference, to make a really informed musical soundscape or set of sounds or composition, but something sonic, some sort of sonic craft, sonic performance, but it's influenced very much by these kind of far right and left observations that then lead to a series of inferences, and then another series of inferences within that, to help design, again, whatever good sound means or good music means. So the next thing I want to talk about, there's a few different things where I feel like I'm stopping and starting a little bit. It does all coalesce towards the end, I assure you. But this next slide is another kind of introductory one, and it's biosensing. So going back to a couple of slides ago when I talked about emergent perception, and there was the brain, which exists in the body, which exists in the environment. This is basically kind of like the practical application of thinking in those terms, where it's not just a case of we can observe the user and try and make some inferences to affect our sound design, but can we directly get data rather than just visual observation of them? Are there other mechanisms, or the tools, or the systems that we can use to get information from that user, but not just the user, from their directly from their brain? So the piece of kit, you may be familiar, I would expect you're familiar with at least one of these. I'm wearing one of them. The Fitbit on the left hand side, but the one in the center at the bottom that says emotive on it, that's an EEG, an electroencephalogram, which is basically, in layman's terms, brainwaves. And I completely forgot where I was going with that. That's the idea, is that that's effectively aiming to go directly to interpret the brain, to try and get some sense of affective or cognitive state relating to the brain. But then we have other things which are kind of that step further out, which are generating information for the body. So just above that to the right, you have an electromyogram, which is meant to be worn on the wrist, and it's basically for detecting muscular activation. So if the user was to clench their fist, all of the muscles in the forearm would tense, and that would be detected by the system. And EMG, as it's called, electromyography, could be connected to all kinds of different things. There's previous work that I've done myself where I've attached it to facial muscles to try and infer kind of emotional expression, but it could be attached to theoretically anywhere that there is a muscle. You could have an EMG applied to detect muscle activation, which could infer things like stress or tension, or it could be used for something else. Again, there's so many different things which these bits of data could potentially be used for, but I just kind of want to give you a rough introduction to what these little bits of kit are. And these are the kind of bits of kit which a lot of people don't think about when they think of virtual and augmented reality. They tend to think very much about augmented reality, they think of a phone, and virtual reality, they think of an Oculus Quest, a headset. And yes, those things are absolutely iconic of those, of these technologies and these experiences, but they're certainly not the limit. And going back to when I said augmented virtuality is where my interest is, and where I would argue the most interesting things are happening, this is very much what I was talking about in terms of augmented virtuality. You have a virtual environment where someone feels present, but feeding into that environment are lots of forms of real world data. And these are some of those forms of real world data. On the top right, you have eye tracking. On the bottom right, obviously, you've got a microphone, so using the voice. There are some really interesting things going on with voice analysis, where it's not just a case of, voice recognition or speech, like speech to text, so that you can instruct the system with your voice, but something where it actually interprets your emotional state by, the quiver in your voice, the tension, the energy flow. It's interpreting kind of your mood or your intent with the way that you're delivering speech, rather than simply just analyzing the words that you're saying. So that sort of data can infer further data, which can then be fed into the virtual environment, and so on. So I will, if there's anyone wants to kind of go back to that and ask about further biosensing, there's more than a reason on that, and I don't want to spend too much time going through all of them individually, because I'm kind of conscious of being as on time as I can with this, so there is time for questions. But I mentioned it a little bit in the previous slides. This feeds on from that. It isn't just a sense of getting that raw data of about heart rate or respiration rate, or kind of, again, muscular tension, those sorts of things. There's lots of really interesting frameworks which have been developed over many decades now. So these aren't brand new. These have been refined over the years, and they've been used in many different applications. I would argue, we just haven't really seen them being used in ubiquitous terms yet. They've just not caught on to that extent. So they're still seen as quite emerging technologies, even though this sort of theoretical framework and this sort of interpretation of signal has been around for quite a while. It's just not kind of latched on as a permanent everyday thing. But these models are ones that I find particularly interesting. So utilizing multiple streams of biosensing information. So rather than just using brain waves, or just using muscular tension, or just using eye tracking, use multiple different streams simultaneously, feed that data into what is called an inference framework. Usually it's data driven, it's machine learning driven, it kind of interprets. It gets better at interpreting the more data you feed into it and that you validate it, but it's used to interpret emotional state. So based on whether the signals are interpretive of a very positive emotional experience, or a very negative emotional experience, or a very intense emotional experience, or a very relaxed emotional experience, you can make certain inferences about what specific discrete emotional state that user might be feeling. And once you know that, and if you can track it reliably, now you have potentially some power to actually disrupt it, to influence it. I don't want to use the word control, but potentially to control it. And I guess in many ways, as performers, as musicians, as composers, a lot of the time that's precisely what we do strive to do. We have a sense of a baseline of where we maybe expect the emotional or the cognitive state of our listener to be, and we know where we want them to go. We know where we need to get them to. And so there's this process that we've probably been doing for generations, for hundreds of years, to be manipulating that particular line. But what this sort of technology does is give us real-time feedback into what is happening, as to whether we actually are following that line. And because we're getting real-time feedback, there's potential here for real-time intervention and actually adapting the material that we're presenting to the listener on the fly. And that's where biofeedback comes in. So you end up with this kind of looping system where the user will engage with some form, and it doesn't necessarily need to be what you call XR or VR, AR, or anything like that, but interacting with some form of system, and that system is generating some sort of feedback to them. They could be pressing buttons, or it could be connected to some sort of like emotion sensors, the biosensing stuff, but some means of interacting with the system. That interaction has an effect on the system. That system then returns a response. And that response, as you see here, is a representation. It could be an audio-visual feedback. The sound could change, the graphics could change, a notification could pop up, but something will happen in response to the way that they're interacting with that system, and then that interaction will change their state, or that's the intention of biofeedback. It will have some sort of meaningful impact on their state. And in terms of biofeedback, it will have a meaningful impact on their physiological state. So measurement of selected physiological parameters, something in their body will change. And because we can kind of timestamp all of this, we get a sense of, well, what just happened in the virtual world and what is happening right now in terms of their in terms of the change in their physiological parameters. We then interpret that change in physiological state, feed that back into the system, and then have the system change what it's doing based on those physiological changes, which then creates more feedback from the system, which goes back to the user, which changes their emotions and so on. And you end up with this looping system which goes around and around and around, which you can design to kind of manipulate that pattern, or to try to manipulate that pattern. So again, I did mention I'm sticking to that again, we are kind of lurching from left to right in terms of different things and coalescing towards the end. So just to briefly give a couple of images to talk about the center at CCIXR. As David kindly said, yeah, it's a wonderful center. There are some really cutting edge bits of equipment in there that I think have got a great deal of application for sound and music. As I mentioned right at the beginning, that's not where most people's minds tend to go at first. They do tend to think about the visual. They tend to think about creating 3D models and textures and animations, and using some of these performative space, or these projection type spaces to project visual type material. And the graphics always tend to come first, and sound tends to become an afterthought, which has been kind of proven time and time again to be a mistake. And that whilst people do tend to get caught up with the visuals whenever an emerging technology comes about, it only ever tends to really create a meaningful, powerful experience when sound and music are accommodated for. And people actually start to think, how can we use this for the auditory modality and not just our eyes? And I think of all these different things, so you've got the kind of the roller coaster simulation tied into the VR headsets in the top right. You've got a photogrammetry rig is the center right image there, which obviously is going to be almost entirely, but it's visually based. And then you've got volumetric video capture, which is video based. But what you don't see here, because the technology is actually a lot more subtle and a lot easier to hide and keep out of the way and to work quietly in the background, which ultimately good technology needs to do, is the audio capture. So we've been able to capture audio equivalents of these volumetric video systems. So you've got like the volumetric video, effectively a person stands in the middle of that room and they can move around, and while that's happening, all these different cameras are recording them, and that's capturing a 3D model of them that can then be replayed in 3D, so that full capture, that recorded capture, could then be put into a virtual world that I could walk around my little avatar around, and I could look at that person moving from as many different directions as I liked, and it would be like there's a hologram of them right there in the room if it was, say, done through a HoloLens. So a real 3D visual representation of a person captured, from a real recording. We've been able to do that with sound recording equipment for a very long time, and the refinement of that technology from a sound perspective is at this stage far better. So what we can do with sound in terms of its overall refinement and quality, again, a little bit biased, but arguably significantly more refined, more advanced than its graphical equivalent, which is playing catch up. And so finding ways to make sure that this audio element is reintegrated into this technology is really, really important. And the last one, just to draw attention to, is the larger image, which is the white light smart stage, which the marketing bump and the main aspect of the main argument for what the value of this is it's effectively kind of like a green screen space, where the person standing in the middle of that screen can be recorded live, that could be streamed anywhere, and then any visual material can be digitally overlaid or underlaid behind that person, so it looks like, think of it like the virtual newsroom, the ITN studio, that sort of thing. But the user, the presenter, the person on that stage gets immediate feedback, because all of that virtual world is simultaneously being projected within that space, so they don't have to use their imaginations like they would do with a green screen. But again, it's all very, very visual. And I remember the first time I saw this, the only really thing that I saw that and thought this would be really exciting for was, can we get some musicians on that stage and do a gig, please? Because that's a really interesting additional layer of dimensional layer of projection that I think would have some really interesting potential capability, some really interesting results to basically for music performance stage design. To create an overall embodied, an overall audio visual experience that really is exciting. And the news presentation, it's fine, it's absolutely fine, but I don't think there's no real wow factor in there. Whereas using this technology for a really one-off, interesting, unique, innovative musical performance, I think is something far more exciting. Again, massively biased, but there we are. And so before I kind of move towards the end and some of the more recent work that I've been doing myself, and just to demonstrate a few specific areas that I've been investigating in my own work, I did want to give you a little bit of a more broad kind of overview of the sorts of interesting ways in which these technologies are being used within music. And I've broken it down into 4 separate categories. The first of which is state analysis. So this is very much going back to the biosensing technologies, all the different sorts of physiological data collected from the human in real time, but then collected at the point of musical performance. So you can see you've got different types of sensors being connected to different types of people. In some instances, it's connected to the performer or the performers. In some instances, it's connected to the audience or the listener. And what I'm particularly interested in this kind of area, the idea broadly is that it's all meant to be real time. So all of this information as they're performing is being collected in real time, and then again, ideally through biofeedback, is being presented. There's some sort of audio-visual feedback based on that data that the performers or the audience have immediate exposure to, which can then influence how they feel, and potentially as a performer, how they play. So they play in a certain way, that makes them feel a certain way, that generates data, that data manipulates something virtual, they experience that virtual thing, and they use that as a way of influencing the nature of their performance. Exactly what that could mean, that's completely open to interpretation. I get as far as, well, this is the affordance of the technology. Now you're asking a very creative question about how you could use that to manipulate, to enhance a performance, change the nature of what a performance even means. But I said at the beginning there, what I'm really interested in, and then I tail off on something else, is that idea of multi-person analysis. So rather than just one performer's data being acquired and then biofeedback and potentially influencing their performance, or one audience member influencing one performer, the idea of more of a collective. This is, in terms of barriers to access, this is not going to be cheap, but having multiple people in the audience, or multiple performers, or both multiple performers and multiple audience members, all generating physiological data that is pooled together or analyzed with reference to each other to get a sense of almost like the room's emotional state, the overall feeling of where the audience is, where the performers are in terms of their cognitive state and their affective state, and then that being fed back to them. So it becomes part of this interplay, not just between a performer and a listener, not just between one listener and another listener, but potentially all those relationships all at the same time. There's so many different relationships in these sorts of setups that haven't been explored at all, let alone to a great deal. And there could be some absolutely fascinating types of performances which could come out of it, some really engaging experiences. And ways of experiencing music composition, live music composition, real-time composition and performance that we've just never seen before. So I've rambled on a bit about that, but yeah, you can clearly tell that's where my heart lies. But that's not the be all and end all. There's other things which are going on with regards to XR in terms of sound and music. Another aspect of that is performance. So what this imagery mainly is relating to or referring to is the ability to experience live music performance in a way which feels more immersive, or more importantly, makes the user feel more present. So again, that could mean a more augmented reality sort of experience where the performer comes to you, where you feel, as the audience member, you feel present in your own living room or wherever you happen to be in the physical world, but we are live streaming audio and visual data to a headset or to your phone or to some XR piece of technology, which gives you an impression that the performer, that the musical performance is being brought to you. You're experiencing it in your own home space, but they've come to you and they're now in that shared space, and you can experience the relationship with that performance in that particular way. Or the virtual reality equivalent of that, where again, the difference is presence. So you don't feel present, you are at home, let's say, but you don't feel present there. You feel you are actually present at the venue, at the actual live musical performance. For me, I think that's where some of the most exciting things are happening. The idea of using multiple microphones, ambisonics, all a really interesting kind of array of microphones or a setup to capture sound, but also the visuals that actually give a user the ability to put on a VR headset and walk around the stage that's being live streamed as that musical performance is actually happening. You know, so if they want to hear the drummer a little bit more clearly, they can literally, well, not literally, virtually literally walk over to the drummer. You know, if they want to be right next to the singer as they're performing, they can do that. They can see, they can really experience it from whatever angle they want, but at the same time, because it's live streamed, it's recordable, they could pause, they could rewind, they could re-experience particular moments of a musical performance with so much more control. Again, whether that's necessarily a good thing, I would leave for debate, but it certainly raises opportunity, opportunity to experience music in new and interesting ways. The next thing I want to briefly talk about, I'm conscious of time and I'm aiming to keep it to around 45 minutes, is space. There's some really interesting things going on that are building on something you'll probably already be very familiar with, which is convolution reverb. So, taking real world measures of real world environments, taking that signal data and then using it to after the fact post-process other forms of other sound wave data in order to kind of recreate the feeling of that particular church, of the Royal Albert Hall or what have you, because it's got the same frequency response. You capture the frequency response and then it enables you to kind of have a virtual recreation of that space. That has been around for a while, but that's starting to find its way being embedded now into real-time VR and AR development systems, such as the new Unreal Engine. So that sort of functionality, which once didn't really fit in the interactive XR space, is now absolutely being considered in the XR space. But it's also being extended upon so that rather than just capturing an environment, these tools are now giving us the ability to manipulate that environment and customize it in any way we want. So if we want the Albert Hall but bigger, we can do that. Or if we want to create a completely new space where the virtual environment is, we build from the ground up, but we determine, the nature of the architectural space kind of within. We dictate the materials and the physical nature of this auditorium, of this space. And then from that, we don't even need to manually manipulate how the sound should respond. It's basically the audio equivalent of what's called ray tracing, where it will just analyze the nature of the virtual environment, and then from that, the system itself can interpret exactly how it needs to manipulate a virtual, another recording that you've dropped into this virtual scene, so that it really feels like that sound is present in that environment. And the sound designer doesn't need to really think too much about the engineering aspect of it. Someone builds that virtual world, the sound designer drops the sound in, and it sounds like it's in that environment, an environment that meets the material properties, the space properties, the positional properties of that virtual environment. It just seems to fit. It makes sense. It works. And then last but potentially not least, I suppose it depends on exactly what your perspective is, music production. There's definitely some interesting opportunities here, I think, particularly using virtual reality for that ability to create these bespoke studios, to give people access access to, it's that kind of next level 3D experience of virtual plugins. And I'm a big fan of software-based plugins. I do quite like physical hardware, it's lovely, but I can't really afford it. So software plugins have always been fine for me. This, I guess, is kind of like the happy medium between the two. Personally, I'm just happy with my plugin. So whether this actually has massive added value, I think it's still in its experimental period. So it's still going to be debatable about whether this sort of thing will take off. But there's definitely lots of opportunities at the experimental level for how you can create these virtual studios, which could positively, hopefully, impact on creativity, on composition, on productivity, and that kind of thing. So I'll just end with one of the most recent projects which I've been working on, which is a little case study of a game that I made called Summoned. And this was going back to that biofeedback and thinking about, all right, well, how can I connect this biofeedback principle with virtuality, with a game with a game experience? But specifically, how can that biofeedback prioritize sound more than anything else? So there's a real sense of how the user state is affecting the sound and how that sound is then affecting the user's state more than anything else. And there's various little bits and pieces to cover here. We can always come back to it. But the principle here is that we're exploring ways in which, again, the user is influencing that world and how that influence of the world is changing the nature of the sound. And that's what's called augmenting sonic virtuality. So you have virtual sound that you're augmenting with real world data. In this case, it's EEG that we're using, as we'll show in a minute. But then the flip side of that is what's called sonically augmented virtuality, which is the use of real world sound to influence the virtual world. So rather than physical data influencing virtual sound, you have physical sound influencing a virtual environment. So you've got kind of two different streams of sound-based biofeedback going on at the same time. And the last thing I'll show you is a little bit surreal, because this has a voiceover that I prepared for a group of my students a while back, but I found it's been useful for some of these talks. But it's a bit surreal because you're going to hear my voice in a second, but it's not my voice, it's the recording voiceover of it. But just to kind of demonstrate how this is working in action.
Before I actually kind of start the game proper, to kind of draw your attention to, which is the biometric interface. We'll get to the microphone in a little while, but with the biometric interface, which I am actually currently wearing, obviously it's not possible for me to kind of on command come across as stressed or unstressed. It may just turn on and off kind of seemingly at random when I'm first starting the game. Obviously the idea is, as the game develops and the environment kind of ramps up the stress levels, you would find that most players would respond to that. Obviously, if I designed the game, it's a little bit different. It's difficult to be scared by your own game. So what I've done is just kind of attach, it's shortcut basically the stress and non-stress threshold to the Z and X keys. So I just press Z, then I can simulate that particular effect. If I turn X, I can turn it off. The principle was basically very simple. Whenever you're not stressed, when you walk around certain areas of the environment, more or less nothing happens. When you are stressed, you're basically a little bit clumsy. So if I turn Z on, as you notice, when I walked into the room, nothing happened there. But whilst I'm stressed, I'm clumsy. But here, I've knocked that over. And when you're clumsy, you knock things over. That makes sound, and that's all about alerting your presence. Alerting the AI to your presence, which we'll get to in a second. So let's just follow the hints and see what we're supposed to be doing there. In development and testing, found that having some sort of hint menu which was optional was very preferable. You didn't want something which was just constantly telling you what to do straight away, but if someone was lingering for too long in a particular space, then a hint menu usually prompted them to move on to the next kind of point of play, but giving them the additional option of just being able to press H whenever they need to access it, just in case they missed that first hint when it came up automatically, was always very helpful. So telling to go to the living room, so I'll do that now. And the idea with this here is to try and use kind of sound to draw attention. Obviously, there's only a small visual change when this message comes up to tell you what to do next. So it was really important that we were able to use something to grab the player's attention and make them look in that particular direction. So having the sound make that little beep, we found very effective for most players. When they walked past that, the minute they heard it, they instinctively swung to the right and saw the screen. So they were then given the next instruction of what they needed to do. Now, once we actually get to the point where I'm summoning the creature, should we say, the problem that we have is that it responds to my voice. And obviously I'm using my voice to explain kind of what's happening at the same time. So the challenge I'm going to have is being able to somehow continue to play this game effectively whilst still talking to you, because whenever I raise my voice, it will hear me, and it will come, basically it will come to find me, but we'll carry on playing. We'll see how we manage to get on with that. So let's just follow the instruction for the time being. Summoned. You try to walk quietly enough, it won't hear I'm sure I got away with that. Although I'm talking now, so it's just heard me out as well.
Yeah, I'm half tempted to let that kind of play out to the end, but I am kind of conscious of time. I just get killed relatively soon. Okay, if I just bring us back to the title page. Okay, thank you very much for that. I hope that was interesting. I hope that raises some kind of points of debate and potentially provocative questions. If anyone would like to ask me anything about the tech or the theory, be very happy to take questions.
Thanks, Tom. That's really, really interesting. There's a hell of a lot there to take in. Just looking at everything you've got there, can you say anything about the costs and where you get the gear from and things like that?
Yeah, I mean, there's, like you make a really good point. Now, there's a lot to say, and usually the answer to a lot of questions around XR is there's a lot of different options. So, you know, depending on whether you're going more augmented reality or virtual reality, it's going to affect the platform. But even within that, kind of what type of experience you want to have, there tend to be a lot of options. I would say virtual reality at the moment is the most stable, because for the most part, virtual reality is very much a headset. And at the moment, there almost literally is just one. There's a few smaller headsets out there, but in terms of the headset, there is only one. There's the Oculus, or the Meta Quest 2, which is currently hovering up somewhere around £300 to £350, I believe. And the way that technology is trying to develop in terms of this affordability issue, which is significant, because until relatively recently, you had what was called tethered VR. So the only way to run it would be to have this headset, plug it into a PC. That PC had to be pretty high powered. So a lot of people who wanted to use virtual reality had to invest in a PC as well. So that plus the headset at £300-400, you were looking at the best part of 3,000, and it was the PC that was the most expensive. What Meta have tried to do, and to some extent this does work for a lot of different types of applications, is invest in standalone VR. So the whole point with the Meta Quest is that you can run an awful lot of VR experiences with just the Quest. So per user or per unit, you should be looking at £300 to £350 for that headset, and you shouldn't need anything else to run the experiences. And I would say particularly another reason why sound and music-based VR is definitely a good thing and should be exploited more is because it doesn't rely on graphics, and the graphics are what necessitate the really high-powered PCs. If you make something which is very abstract and not very computationally heavy, and it's all about the sound, then you can create these really vivid and detailed environments and experiences that will run very comfortably just on the headset by itself. So it's a lot more affordable in that way.
So wonder where this is going to go with, you know, the sort of secondary school taking this up. You know, are we going to see instead of 20 computers, 20 headsets, and then what program will they be using to?
Yeah, I mean, and this is a really good question. I mean, I would say no, almost certainly not. I mean, it's not just a case of having, say, like 30 headsets per student. You know, having to manage a classroom with 30 students with the headsets on would be an absolute nightmare. But also the amount of space you would need to safely deliver a 30-person. I mean, like we have 20-seater lecture workshop classrooms with PCs in them, and that can hold 20 students each at a PC. If they're all developing VR, we have to half that number to 10. Only 10 people can work safely in that space because you're getting up and you're flailing your arms around and you're using a lot of space. So unless you also happen to have an awful lot of space, you can't do it. There are two really interesting cheats, though, that I found work very, very, very effectively. So no, they're not. I tell you, it's one. They just kind of two. They've got kind of two sides to them, and that is kind of is to have one user in VR, and then the rest of the class are basically interacting, but without the headset. Now, this does tend to, unfortunately, need a PC, because what you do is you have the VR is being the images that the user is seeing are being streamed and they're being projected on the whiteboard. So the rest of the class can still very much engage because they can see what's on that. And there are also some really interesting technologies or things that are being developed that's called asymmetric multi-user. So you've got one student who has the headset on and they're using the affordances of the VR experience, and everyone else is interacting with either a phone or just the PC interface, or they're not into using any technology. They are, I'm thinking like the Crystal Maze, where one person is actually doing the physicality, but the rest of the cohort are working together to solve some sort of cognitive challenge to then explain the answer to them. So they're all working collaboratively, but in different ways, but they're all engaging with it. And in those scenarios, you only need one headset.
So I wonder why it's not really hit mainstream education as yet. Is it just, which department does it fall into? Is it the music department? Is it computering department? And you know, is there confusion there as to who should be taking this forward? It seems to be a bit static at the moment.
Yeah, absolutely. I mean, I think that there's multiple reasons I think it connected into that. I mean, for one thing, the scenario that I just described hasn't really been very well kind of marketed, really. I think everyone, when they think of a VR classroom, they still think of 30 headsets at the same time. And the idea of doing this kind of asymmetric approach, they just haven't really thought of. But also, this isn't something that, it's not like the teachers or the educational institution can just, they can just use it in that way. You know, the software needs to be designed to facilitate that. And that is where there's definitely a really big bottleneck, is in good design. You know, I think a lot of the time that the process of developing for VR is more complicated than for a traditional virtual kind of tool. And in fairness, I mean, just normal, games for schools and so on, still don't tend to be taking off as well as they could potentially. I think there's just not been enough research that's gone into how it can be deployed most effectively. Particularly, and then again, the benchmark is pen and paper. If you can do it with pen and paper, that's very cheap. So there's got to be some added value, and in many cases there simply isn't. But in some there are, and I think the research at this point is it's still not sure where those real points of added value are. Are they in music? Are they in physics? Are they in maths? The data just doesn't exist yet.
Yeah, I mean, it's seeing those case studies, and then of course it's going to come down to the phraseology. What's the learning outcome?
Yeah, absolutely.
And that's it's putting into the education speak within those secondary school settings. That what are you going to learn by spending all this money on this gear? Which programs are you going to use? So it's all very well having the hardware, but then which software do you use that's got the sort of tick of approval, I suppose.
Yeah, absolutely, and even within that, there's still so many different variations. So some of the interesting things that we've seen it being used for have been in training more to do with criminology than anything else. So anything or kind of environmental science, anything which is focused on scene analysis, because you're, again, VR. This is very much VR, but you're immersed in that virtual space. So the act of looking around and interpreting your environment to infer something that you would then do, and you would apply that in the real world. There's a nice clear transferability of the skill. And I think that's the trick really. So for example, if it was music education, it would be, you know, what would be the transferability of the skill? And I think that needs some creative problem solving, really. I think that there are some ways it could be potentially very interesting as a means of education within music education, and particularly for engagement, I suppose, to get people who haven't really thought about getting into it as a subject to get into it. But I think we need more than that. You know, you need something with more of a tangible, it develops procedural knowledge. But the other thing is obviously anything which is skill based is very, you know, it's not very psychomotor, very physically based. The technology isn't really there yet, but it could be very close, because we have all of the basic tools for it. Again, when people think of VR, the interaction is still headset and controller. You can't play a guitar whilst holding the controller in your hand, but I mean, AI image recognition, real-time image recognition and motion tracking could perfectly easily, actually, it's competent now for being able to analyze. So I could pick up, this is university bought guitar, thanks Portsmouth. Part CCIXR, cheers for that, it's lovely. But the type of technology that we've got to actually be able to, you know, I could just not have to wear a headset, or I could not need to use any controllers. I could just sit here and play, and with the right cameras in the right position, that could be collecting data and interpreting it and then feeding it back onto a projection screen or something else, something which is a bit more installation based and doesn't mean I need to put a headset on. And then if you can do that with one person, you could maybe do that with 3-4 people in the room. And as long as you've got a good rig in the ceiling, it doesn't take up real estate. You know, there's definitely some potentially exciting things, but those bits of technology are still very expensive. So yeah, there's always something in the way, I must admit.
And then you need the pedagogy to go with it, and then
yes, absolutely.
What's the whole system? What is that there? Really interesting, David.
Which begs the question of yes, so how long is the learning curve to be able to develop some of the very complex things that you've been talking about? Yeah,
I mean, at the moment, it's even there's two kind of parts to that. The first is kind of what's the learning curve for like someone who actually wants to be a virtual reality developer, who actually wants to develop applications, software experiences using the professional industry standard tools to produce that kind of content. And that's quite steep. You know, particularly from scratch, there's an awful lot of fundamentals you need to cover. And then particularly if you want to do the more interesting or potentially more powerful stuff, that requires you to have a really good understanding of simulation, which we're talking maths and physics. You know, there's an awful lot of underpinning knowledge which requires for a really adequate simulation. But even the fundamentals of design, it's still quite a steep learning curve. And then as for this other group that I was alluding to, people who are not VR experts and don't want to be developing anything from scratch, but they would like to be able to maybe make bespoke experiences at a kind of modifying level. So when you think of more like Moodle or a virtual learning environment or a WordPress on the internet, you know, you're not actually typing in code in HTML, but you've got all the tools to just drag and drop, and who can it have this, and can it do that? A content management system. And that's one of my projects right now, is actually trying to develop a content management system with VR capabilities. So like a VR extension of Moodle, of a virtual learning environment, where other users, where there's kind of like the administrator level users, so not the student level users, but the teachers, the educators, they don't need to be programmers or anything like that. They can use it like WordPress to add their own content, to upload text and images and videos, and it's relatively easy without a huge learning curve. But obviously, for us to give them power to manipulate something exactly as they want, whilst it being easy for them to manipulate those things, requires us to make an extremely refined and robust system. So yeah, it's exciting. it's still a massive challenge, and that's just even at the moment we're operating in very focused contexts. You know, where it's just 1 or 2 learning objectives for a very specific academic discipline. So the idea of a system which is like discipline agnostic, where you could use it for physics as easily as for music, again, theoretically, it could be possible. There's no reason why, as this technology develops and as our with enough investment in a system, it could perfectly, you could create a content management system with zero learning curve. We're not there yet. It would be a while.
Thank you very much, Tom. I've myself got an awful lot from that. Certainly the complexity that is behind all VR. So thank you. And we're going to have to finish there. We could go on talking all night.